Okay, guys, in this lesson, we're going to continue to factor quadratics, but we're going to look at two special cases. The first special case is a perfect square trinomial, and we're going to learn how to recognize a perfect square trinomial and be able to factor it very quickly. But first, let's see how perfect square trinomials are created. They can either be in the form of the sum of two terms squared or the difference of two terms squared. So remember, when we have a binomial and we're squaring it, multiplying it by itself, we must write out the binomial and then do our double distribute. We can't just square x and square 4. That is not the correct answer. We're going to end up with a quadratic trinomial with three terms. So we multiply the x times x and x times 4. Then we distribute the 4. Notice the middle terms are exactly the same. That is going to happen every time. And so we have created a perfect square trinomial. What that means is our first and third terms are positive perfect squares. They have to be positive because anything multiplied by itself will give me a positive. The middle term is doubling the product of the root of the first and third term. So the root of x squared is x, the root of 16 is 4, and if we double 4x, we get 8x. Now let's take a look at x minus 3 times x minus 3. We get x squared minus 3x minus 3x plus 9. Again, the middle terms are the exact same terms. That's where the doubling comes from. We have a perfect square trinomial. Our first and third terms are positive perfect squares. If I multiply the roots of these, I get 3x. If I double 3x, I do get 6x. And it's okay that we have a subtract here. We will never have a subtract on the last term for a perfect square trinomial. Now let's multiply 2x plus 1 times itself. Again, our middle terms are the same. This is a perfect square trinomial, and being able to identify these is going to help you factor quickly. So these are both positive perfect squares. If I take the root of 4x squared and multiply it by the root of 1, 2x times 1 is 2x, and if I double 2x, I do get the 4x, the linear term. Okay, so here we have a perfect square trinomial. To recognize a perfect square trinomial, anytime that I have a trinomial and the first and third terms are perfect squares, I check to see if the product of the roots doubled is the middle term. So the root of x squared and the root of 9 multiplied gives me 3x, and 3x doubled is 6x. So this is a perfect square trinomial. However, if you do not recognize a special quadratic, it is okay. You can always go back to using the graphic organizer to do the grouping method. But if we recognize that this is a perfect square trinomial, let me show you the quick way to factor this into its two binomials. We take the root of the first term, the sine of the middle term, and the root of the third term. So root, sine, root. So I take the square root of x squared, x and x. I take the root of 9, that's 3 and 3, and I take the sine of the linear term, and these are the two factors. Then we can write this as x plus 3 quantity squared. So again, each term contributes to the factor, the root, the sine, the root. Okay, let's take a look at our next example. So we always need to ask if there's a GCF, and there is here. So they are even numbers. So I have 2 times then x squared plus 16x plus 64. Now I can see that my first and third terms are perfect, positive, perfect. And let's see if the product of their roots, if doubled, gives me 16. So again, I still have my 2, my GCF. Here, I take the root of x squared and the root of 64. That is 8x when I multiply them. And if I double 8x, I do get 16x. So this is a perfect square trinomial after we factored out the GCF. So we're going to take the root x. We're going to take the sign of the middle term. It's plus. And then we're going to take the root of our third term, which is 8. So we can leave it like this, or we can go ahead and simplify a little bit further. And 2 times x plus 8 quantity squared. So this has 3 factors, 2, x plus 8, and x plus 8. Okay, let's take a look at our next example. We do have a GCF, so we're going to factor out the 3. So we have 3 times x squared minus 10x plus 25. I notice that my first and third terms are positive perfect. I take the root, and if I double 5x, I do get the 10x, so it satisfies being a perfect square trinomial. So I set up my 2 binomials. We take the root of x squared and break it down into x and x. We take the sign of the linear term, minus, and then we take the root of 25, and that's 5 times 5. I can write it as 3 times x minus 5 quantity squared. And again, if you do not recognize this being a perfect square trinomial, we can always use the grouping method and our graphic organizer. Let's do a couple of more. There is no GCF. My A is 1. X squared and 144 are positive perfect squares. If I take the root and multiply, I get 12x. 12x doubled is 24x. This is a perfect square trinomial. Decompose x squared into x and x. So the root, take the sign of the linear term, and then take the root of our third term, 12. So we can combine that and write it as x minus 12 quantity squared. We do not have a GCF. We have a perfect square and a perfect square. If I take the root of x squared and the root of 100, if I double 10x, I get the middle term of 20x. So this is a perfect square trinomial. So I'm going to take the root, the sign, and the root. And here are my 2 factors. So this is factoring a perfect square trinomial. We'll say root, sign, root. And again, if you did not recognize this, we could say 1 times 100 on top. Our middle term is 20. I could think of my factors of 100. I could notice that 10 times 10 gives me 100, and it adds to 20. And so those would be my 2 middle terms when I split the middle, when I split 20x. And then maybe at this point, especially when you get the same factors on each side, you will probably recognize, oh, that's a perfect square trinomial. But if not, you just continue on with your grouping. I factor out the GCF, and then the GCF. And then I would take the GCFs of each term and then times the common or shared term. And here we have the same answer. So either method works.